So what we're going to have a look at today is the normal distribution, and this sort of works in really well with exercise 1405 in the Maths in Focus textbook. If you want to jump into Desmos, what you can do is graph the curve or the function e to the minus x squared, and if you do that, it will look kind of like this. Maybe a little bit nicer than that, but it'll look very similar to this curve here, which you may have seen on your HSC formula sheet, but that's what we're going to be having a look at. This is the normal distribution, okay? So it mimics e to the minus x squared. We don't need to know that too much, okay? The normal distribution is a special continuous probability distribution. So it's a PDF, it's special. This is the topic that starts to overlap with standard maths a little bit. Okay, so we'll find a lot of the questions in the standard maths HSC section. It's often called a bell curve. And what makes this really special is the mean, the median, and the mode are all equal. And we know that the mode is the most common and it's the highest point on that curve. So this little point here in the center, we'll point there, or the value down the bottom here that relates to that is our mean, our median, and our mode for that kind of graph. And it's a graph that's used a lot. If you go to uni, you'll use this a lot in your statistics subjects or your psychology subjects. And we need to get really familiar with it. It's symmetrical, okay? So it's perfectly symmetrical. That's the first thing we want to look at. And what we normally do is the center of the graph, which is our mean, we write as mu because we know mu is our mean, okay? We're calling mu, mu. It's our mean, and what we show are these separate lines that are moving away in the positive direction and the negative direction away from the mean, and they're our standard deviations. We've got SD, which is standard deviations. And we've looked at standard deviations and variance before, okay, and we call that guy sigma. Or if you just want to call it mean and standard deviation, that's okay as well. So we're going to look at this in a lot more detail in terms of percentages and what's on the formula sheet in the HSC. But basically, if we've got our mean, our first line here is our mean plus a standard deviation. And then our second bar or line here is our mean plus 2 standard deviations and plus 3 standard deviations. And the other way, we're going to be the other side of the mean. It would be the mean take away 1 standard deviation, take away 2 standard deviations, and take away 3 standard deviations. So if we were to draw our own graph, sketch a PDF of a normal distribution, which is what this shape up above is, with a mean of 8.3 and a standard deviation of 1.2, we would say, well, our standard deviations, or these lines that go up here, 8.3 plus 1.2, plus another 1.2, plus another 1.2. On the other side, we take off 1.2, take off another 1.2, take up another 1.2. Okay, so they would be our means and standard deviations. But what we're actually going to have a look at, which we're kind of introducing it a little bit differently to how I probably would like to. We're going to call these our z-scores at the bottom, and we're going to have a look at what that means a little bit later. But for now, we're going to say, well, let's allocate a value of 0 to our mean, 1 for our first bar here, 2, and then 3, and minus 1, 2, and 3. We're going to have a look a little bit further on down what that actually means, but we could allocate those, what we call z-scores to it. Now, what we have below, and actually I've got one to the side which I've pasted into your questions from your textbook, but it's a table, a probability table for the standard normal distribution. And the value in the table is the area to the left of the probability, or probability that's less than the z-score. So our z-scores are the values underneath here, okay, that we've allocated. Basically a position at this point, we'll think of it as, in relation to the mean. So what we would have, and I've actually got a better one over here, a nicer one. So on the left are our z-score values, okay, and along the top is another decimal place of our z-score values. So if I had a z-score value at the bottom of minus 2.3, then my value that I'd have there would be 0.0107. So if I times that by 100, I'd say that, oops, that's 1.07. So 1% of my probability or scores would lie to the left of a z-score of minus 2.3. That's what that's saying. What we would find though is if I go all the way down the bottom here, a z-score of 0 is our mean. That's the centre. So 50% or 0.5 is the area to the left of that value, which is what we've figured out before. And that's what we've been working out. Okay. So when we're looking at these curves, what we want to think about is the curves are symmetrical. So what I have happening, for example, at this -3 line here, or the 4.7 in this case, to the left of that line is going to match the numbers to the right of the other side of my curve because they're symmetrical. So we want to think about that, and we want to think that, oh, this is an even curve, and we've dealt with these before. Okay, so let's have a look at the first one. So it says, for a standard normal distribution, use the table to find the probability that z is less than 0.6. What does that actually mean? So let's draw ourselves a little table. We'll put our mean in the center, and that's going to be our 0. We've got our nice symmetrical curve, and 0.6 sits in there somewhere. Okay, it's less than 1, but it's on the positive side, so we want to find this area in here. Okay. Now, if you have a look at my table here, I don't have a value for 0.6. Do I? I definitely don't. I have a value for minus 0.6. So I need to figure out how I can use my symmetry to work out what the area is to the left of this curve. And you might find that you do this slightly different to me, but I'm going to pop a 0.6 in there, and I'm going to pop a minus 0.6 in there. So what I know is that if I think of what my blue area is there, okay, I can work that bit out from my table, this blue part in here. So the probability that x is going to be less than or equal to minus 0.6 I can get from my table. So let's do that. So minus 0.6 is going to be 2743. That matches up with the 0 at the top, so that's right. So we go, where are we? 0.2743. Just 0.2743. I know the area under the curve from 0 is going to be 0.5. So I can work out what this part in here is as well. So that part in there is going to be, and that's going to be between 0.6 and 0, and that's going to be 0.5, take away, oops, sorry, 0.2743, which gives me 0.2257. So I now know what this part here is, between 0 and 0.6, that's going to be 0.2257. So I know now that that's 0.2257. To the left of the 0 is 0.5. So the probability that I want for z being less than or equal to 0.6 is going to be the 0.5 to the left of the 0 plus the 0.2257. And that's where my 0.7257 comes from, which is 72.57%. So that's saying that to the left of the 0.5 z-score, there's an area of 0.7257, or my probability that scores lie that side of that number is 72.57%. So we need to look at the symmetry around the curves and see what we can work out from that. Let's look at the second one here. Okay, so here we are. So find the probability that our z is less than or equal to minus 1.83. So there's our 0, minus 1, it's down here. We want to find basically this area in here. Let's go back to the curve. 1.83 or minus 1.83. So minus 1.8, that's 0 decimal places, 1, 2, 3. 0.0336. That's the number I've got there. As a percentage, 3.36%. That's our answer for that one. Okay, now find the probability that our z is greater than or equal to 1.06. So what I am going to do, there's my answer, but how I'm going to do it is I'm going to think of it as, well, there's my 1.06 there, okay. That's going to mirror what I get when I have a number down here. So that's basically going to be the same as the probability of Z being less than or equal to, I'm going to get rid of that actually. Let's rejig that. Okay, let's rejig that. So the probability of Z being greater than 1.06, and that's a little bit better, is the same as we're going to have Z values less than or equal to minus 1.06. And if we go straight to the chart, we're going to read off 0.1446. I don't even need that bit there. So let's go back to the chart and have a look. What's our value again? Sorry, guys. 1.06. Okay, so 1.0, 1.00, 1.01, 2, 3, 4, 5, 6. That's 1.06, 0.1446. And that's my answer there, which is 14.46% of scores are going to be greater than 1.06. Okay, next one. The probability that our Z is between 0 and 2.34. Well, we know that from 0 upwards all the way to the end is going to be 0.5. So if we work out what is going to be bigger than 2.34, and we take away our 0.5, we're going to get our answer. But I'm going to think of it as, well, this part up here is going to be mirrored by the minus 2.34 down here. So if I work out what my Z values are going to be for minus 2.34, let's have a look at that. Minus 2.30, 1, 2, 3, 4. Hang on, are we up to 2, 3, 4? That's right. 1, 2, 3, 4. 0.0096. Okay, so we've got a Z score of less than minus 2.34 is equal to 0.0096. So that will mirror this amount up here. So to get the dark blue part between 0 and 2.34, we're going to go 0.5, which is the whole lot, take away the pink bit, which is 0.96, to get our solution. Part E, a little bit of jiggling around for this one. So we want to find the probability that our scores are going to lie between minus 2.18, so the other side of the minus 2, and up to 1.23. So what we can do is figure out what the probability of our Z is going to be less than or equal to 1.23, and take away what is going to be less than minus 2.18. So that'll be the whole amount from 1.23 down. Take away this little pink section, we'll get us our solution. So there's various ways that you can do this one. So what I think I'm going to do is first of all look at the probability that Z is going to be less than or equal to minus 1.23, which is that bit there. And that will allocate me all of that part in there. Okay. I don't need that in there, but that'll allow me to mirror this part up here. Okay. So the probability that Z is less than minus 1.23 on the table is 0.1093. So go and have a look at that. So then if I go 1 minus that part up here, which I've worked out from the other side, I'm going to get everything that now is down in there. Okay. So 1 minus the 0.1093 gives me 8907. And that's now my new pink section all the way down here. Okay, that's saying the probability that my scores, or the probability of getting a Z score less than 1.23, it's 89%, so it's fairly big, and that relates to what my graph is. But I don't want that. I want to have this part that's less than the minus 2.18 taken out. So if I now go back and have a look at what that's going to be for Z scores less than minus 2.18 on my table, I'm going to get, and just be careful and double check your values the same as mine, 0.0146. And that's going to be that tiny little end bit. Okay, that's this end bit down here. So if I now take away this little end bit that I've just popped in, I'm left with the bit that I want. Oops, taken too much away there. I'm left with that tiny little bit that I want, which is going to be, we might get a highlighter, oh, we might do the green bit, between minus 2.18 and 1.23, and I've got everything in there. And I've got an answer of 0.8761, which is 87.61%.